In this video, we're going to start or continue talking about motion. Okay, after a lot of hard work and trials, I was able to make a following graph using that CBR sensor we talked about. So, just notice a couple things about this graph right away. We've got distance in feet, time in seconds. So the question is, how did I walk to make this graph? Well, I started right next to the CBR, and I ended up approximately let's say 2.5 feet away. And how did I make that happen? Well, I walked at a constant rate. Okay, so I want to make this video short, but let me just maybe write that down. You walked away. And the important word here is at a constant rate. Okay, and that's really key here. So yesterday we talked about the fact that the derivative of position or distance is velocity, and what would that graph look like? Well, let me graph that in red right up here. Since this has a constant slope, it's just linear, it looks like it's about over 4 up 1, looks like about 1/4. That means the derivative would just be a horizontal line at about 1/4. Now the units for velocity, well, since it's the derivative of position, it's let's put P for position, dP dt. My position is in feet, time is in seconds, so there's my units. We can use Leibniz notation, remember, since the velocity represents the derivative of position with respect to time. Position was feet, time was in seconds. The next question is, how would I walk to make a velocity graph look like that? So now it's no longer, let me just cross off the distance here, it's no longer distance. This up here would represent velocity. Okay. Well, of course, if I started with a velocity of 0 and I ended up with a velocity of 2.5, what had to happen? Well, I had to speed up or accelerate. Okay. So the answer is you'd walk away, but you'd speed up as you walked away. And that acceleration would be at a constant rate. So you'd accelerate at a constant rate, or speed up. Okay. Now, if you took the derivative of velocity, what would the units be? Well, derivative of velocity would be dv dt, right? Velocity, we already said the units were feet per second. Well, time was in seconds. So again, we're using our Leibniz notation. I'm just doing the units by that. The units on velocity was feet per second. The units for time was seconds. So it's feet per second, which I'm sure you've seen in a science class is feet per second squared. What does that represent? That represents acceleration.